Okay, welcome everybody to this 8 Associates webinar on reducing your building's footprint with life cycle assessment. So just a little bit about 8 Associates, or we refer to it as 8. We offer a wide range of sustainability services for the built environment and beyond. And I've been here for now a couple of months, and it's been very interesting to see the range of backgrounds of people here that are all focused entirely on sustainability in this practice: architects, ecologists, BREEAM specialists, all kinds of great people who are working towards sustainability. And about me, so I lead the Building LCA team here at 8, and we deliver whole life carbon assessments, circular economy assessments and statements, and all kinds of LCA work for buildings and other structures. So I'm an expert member of the BSI B558 group and the CEN TC350 group, where we develop LCA standards for buildings, which is it's a European set of standards that is used in Europe and beyond, and underpins a lot of the other standards that people use. Originally, I was a designer. I worked for 10 years in various architecture practices as a designer. And then following that, I spent 10 years working at BRE, working in these sorts of areas of LCA, circular economy, responsible sourcing, and led development of much of the content in BREEAM manuals on those areas, and also the BRE impact tool and database. So that's just a bit about me. So just to start off with, I think it's good to just explore what is embodied carbon. So in a nutshell, really, it's greenhouse gas emissions, CO2 and other gases that cause the greenhouse effect from building materials and construction activities linked to the building process. And so just pulling out a few things there, you can see, building services, equipment, the roof, materials in the roof, stairs, ramps, frame, internal walls, all the different bits of the fabric and materials and products in a building would be included in embodied carbon, and the emissions that come from those, from the manufacturing process and processing and all the other stages in the life of material. Also, what's included is the construction process as well, but also the repair and replacement of materials during the life of the building, as well as the demolition, deconstruction and processing and disposal of materials at the end of life. So all of that's included in the embodied carbon assessment, along with transport to site as well. So from the factory where the materials are made to the site would be covered. So just a bit of disambiguation. So comparing embodied to whole life carbon. So whole life carbon is what I've just explained about embodied carbon, that scope plus operational energy and water, greenhouse emissions gases from those two things as well. So this is where you're talking about the power used in a building, the energy used for heating and cooling, the water that is used in a building as well. And so it's effectively the entire carbon emissions of the building throughout its entire life, including all of the various sort of uses and activities going on during its use. So what do we mean by whole life? Really, it's the emissions that occur over this concept of a whole life of it. It could be a product, or it could be a building, or any kind of anything that you can assess, any kind of object that you can assess. And so a bit of terminology, what we call the upfront emissions, you can see there on the diagram. So that includes the construction product supply chain, all of the carbon emissions that occur from the origins of the product right through the processing, transport, and then the installation on site. So this is an upfront emission scope, is all of the emissions up until the point where the building's ready to be used at practical completion. Then following that, when the building's occupied, you have the in-use emissions, and that's like the longest period of time. Typically, we tend to use 60 years as a good rule of thumb for studying that period of a building's life, and some buildings are shorter, some are longer. It's difficult to say. So 60 years is seen as a good kind of way to test the performance of a building over a longer period. And so that's all of these operational emissions from energy and water. Then following the end of the life of the building, you of course have end of life emissions from the dismantling and demolition, and then transporting those materials or processing them on site, transporting them away from site to be processed somewhere else. And you kind of hope that with the circular economy, and traditionally a lot of materials have been reused, like metals, for example, with high value, that a lot of these materials are extracted and they are sent off to be reprocessed, recycled, reused, and then re-enter a new life as at the beginning of the next building's life. Unfortunately, though, a lot of materials do end up being disposed of permanently in landfill or in incineration, for example. So that's kind of an example of the whole life of a building and the different stages, and we'll go into that in a bit more detail. So just as a kind of an example here of one part of a building, a brick. So you're looking at the raw material supply there on the top left-hand corner. So in this case, it'd be the extraction of the clay, and then that would be processed, as we call it. That effectively manufacturing. So lots of energy used in turning the clay into bricks, and other additives perhaps are included, maybe not. And then you have your finished brick at the bottom there. And that's the emissions up to that point are known as factory gate emissions. So the bricks are ready to be taken somewhere where they're going to be used. And that stage clearly is called a transport to site. There may be some intermediate spots in between, where they're with a supplier or something else, but effectively it's that journey to the site. And then you have the construction installation process. A guy there laying the bricks, and there are emissions associated with that. People being on site, the porter cabins on site, or energy and water used during the construction process. All kinds of various things are captured in that stage. But then once it's installed, in terms of the brick, that's kind of its point where it's reached that upfront emissions point, and then after that you have repairs, which could be repointing or maybe cleaning, maybe replacing some damaged bricks, that kind of thing. So that's your repair and maintenance. That's that 60-year period, and bricks tend to be pretty solid, robust things, don't require a lot of maintenance, but maybe a bit. Then you have your end of life emissions once the building has been decommissioned, not going to be used anymore. Hopefully, I'll come on to this in a minute, but we should be reusing building structures in situ as far as we can. But ultimately, at some point, a building will be demolished, no doubt, and then the materials can be sorted on the site. In this case, the bricks could be removed in a way that means that they're not damaged. So, for example, if they stuck together with lime mortar instead of cement mortar, then that's possible, and they can be bricks are often from older buildings are reused. But unfortunately, some of them may not. They might be crushed into secondary aggregates, or they may be disposed of in some kind of disposal process like landfill. So just a bit of terminology on this. So if you get involved in anything to do with LCA, embodied carbon, whole life carbon, even if you're not doing it but you're looking at results, you'll start to see these kinds of terms in the analysis. So it's worth spending a little bit of time looking at them. So you have those upfront emissions, and the product stage A is broken down into individual steps. That's not often something at the building level you would particularly look at. That's perhaps more of a product level LCA to look at those A1, 2, and 3 stages. But then you've got these steps I mentioned, like transport sites A4 and construction installation A5 and so on in use. Lots of different, very similar sounding B1s, B2, B3, B4, that all have a sort of slightly different definition there. In the use one is often used for, fugitive gases from insulation products, perhaps, or leaking from HVAC systems and carbonation from concrete. So all of the various emissions and various things that happen in the life are captured in one of these modules somewhere. The operational energy and water B6, B7 are included in that in-use phase, of course, but they're obviously a bit different because they're not part of the embodied scope. They're part of the whole life carbon scope. And then your end of life, which I've covered around deconstruction, transport, disposal, etc. And then there is this module D it's referred to in the next life. So all the other steps I've talked about represent the life of that particular building that's being assessed. But it's recognised, obviously, a lot of materials can have a second, third, fourth, fifth life, and that's captured in this module D. So you can show, based on current practice, how much the benefit of a material that can be used in a second life. And it's not something you include, you add on or you minus off of the total for the life cycle of the building. It's just reported as a separate bit of information. You can also have what are called loads, so negative, unwanted effects in that stage too. So just to touch on this upfront carbon emission scopes, that's in terms of these kind of codings, it's A1 to A5. Whole life embodied carbon is A1 to C4, so it's all of them except for B6 and B7, the operational, and then whole life, of course, is all of the A1 to C4, so A to C, but as I mentioned, not including D, which is reported separately. So why is embodied carbon an important thing to consider? The UN looked at the emissions for the construction sector and buildings globally back in 2019, and they came to the conclusion that a very significant amount of emissions from buildings comes from buildings in the construction process, 39%. In fact, of CO2, so that's not even including other greenhouse gases. And of that, a significant proportion is not due to the operational energy, it's due to materials, and particularly the main construction materials of steel, cement, glass, the embodied carbon, the products and materials side of carbon emissions from buildings. So that kind of shows that it's an important thing to consider, and this is globally, and the situation is going to vary from one country to another, particularly where countries have really drilled down on controlling operational energy, where the balance starts to shift towards embodied, which I'll come on to in a minute. Unfortunately, the report also shows that even though many of us are aware of attempts to reduce carbon emissions, through various sustainability schemes and net zero carbon and so on, the emissions are increasing from the buildings and construction sector across the globe, and that's largely due to growth. So we need to somehow be able to have growth but also not increase emissions at the same time, and that's not happening right now. So that's something that really needs to be tackled. And also just to look at how embodied carbon emissions compare to operational, because people often think about operational as the main thing to tackle. Traditionally, it's been part of regulation and so on. And the things to point out around this are that that embodied is not regulated in most countries. Very few, there's one or two exceptions, but really it's not. It's just it's not. There's no laws, there's no regulations, no building codes typically that try and put minimum kind of performances or put caps on how much you can emit. So it's very much a voluntary area still. And in newer buildings that have got high energy performance, as I've touched upon, it can well be that embodied carbon emissions are equal to or can exceed the operational, particularly on buildings with very good levels of energy efficiency, or buildings that don't use very much energy, perhaps like some industrial buildings. And there's a subtle point here too, that unlike operational, where you can reduce the emissions year on year, so you could look at optimizing performance of the kit you've got by through more sort of specialist commissioning, or just general energy efficiency measures by the organisation who occupy or run the building, or you can upgrade the kit at some point in the life of the building to more efficient kit, or install perhaps PV to contribute a bit of electricity to the grid to offset what you're using, or you can consume it on the site. So all those things you can do with operational, unlike with embodied, where pretty much a very significant proportion of embodied emissions occur at the right at the beginning, the upfront emissions, and those emissions have happened. There's nothing you can do about it afterwards, and that's why they're so important to tackle right at the beginning. And also, of course, the electricity grid decarbonising is something that will make buildings apparently more and more efficient, as the energy they use is less carbon intensive. Doesn't obviously apply to gas, and that's another thing that's not really going to apply to embodied emissions very much. However, the embodied emissions are coming into a lot of industry kind of standards and initiatives, really. So UK Green Building Council's Net Zero Carbon Roadmap, the RIBA 2030 Challenge, and LETI produce a lot of useful guidance documents and benchmarks that you can use, and so it's really kind of been put on the agenda along with the whole net zero carbon driver that's there as well. So it's massively increased in terms of awareness and interest in the last few years. The last point there is that it is starting to enter regulation in one or two areas. So the Greater London Authority now requires big projects which are called into the GLA to have a whole life carbon assessment carried out, and a circular economy statement as well. So that's the example of, that's through the planning system where it's starting to become kind of, I say regulation in speech marks there. So how do we minimise embodied carbon? So these points are around looking at the asset level, the building level first of all, and circularity there. And so the sort of first few kind of quite basic questions are, is there definitely a need for the project? I mean, do you have to do the construction work, or is what's there at the moment sufficient? It seems like a slightly odd question to ask, but it's always worth sort of thinking about at the beginning. And if something does need to, if some works are needed, what's the minimum that can be done in order to fill the function? And do we have to, how much extra floor space do we need? How many extra floors, perhaps on an extension, that kind of thing. So just trying to really focus on what's the function, and not trying to consume construction products unnecessarily, because that means more carbon emissions. Another question to ask is, will the building or the facility be fully utilised when it's finished? If not, is it because there's a plan that it will be over a period of time? So these are just sort of fundamental points to ask. And I know clients are obviously going to think about this very often, because it's going to cost money to build buildings, but it's also worth looking at it in terms of carbon as well. So let's say a building is a construction product is going to happen, and those questions have been looked at. The next thing is really to think about how can we minimise new construction, i.e. new products. How can we maximise reuse and refurbishment of existing assets? And this is really on the agenda now. Planning departments, I constantly keep hearing, are asking tricky questions around this. Why do you need to demolish the old building? Can't you use it, or some of it, or something like that? So that's definitely something that's, if you're using existing structures, then you're typically going to be saving carbon, because you don't need to procure as many new products. You don't need to do as much construction work on the site. You're saving waste from demolishing that probably wouldn't have been used, and so there's all these sort of benefits from reusing existing structures, which does present a challenge, but it's I think probably a healthy one. But if you're doing that, you really need to be bringing the building up to best practice performance, because you need it to have that longevity. It needs to, last the 60 years or whatever it's going to be, not need to have lots of works done down the line or just within a few years because its energy performance isn't very good, for example, and suddenly it needs to be redone again, which wouldn't be an efficient use of materials or anyone's time. The other thing is that at the building level, you've always got this, and particularly with refurbs, you've got the trade-off of the operational and the embodied carbon emissions. So if you install a load of new efficient HVAC kit and get rid of the old inefficient stuff, or if you put lots more insulation in, or you do triple glazing, sounds all like great things to do, and often is. But each of those things means more new materials, so it means more embodied carbon emissions, and you don't really know, at what point that you're going to get the payback point for the emissions from the products in terms of energy efficiency. So that's what you use whole life carbon assessment for. You can start to answer some of those questions. And then, the last section there is designing for resilience, and this is more of a longer term consideration. You're looking to avoid early obsolescence. You don't want to emit all this carbon for a building that is going to, in a few years, or is going to be obsolete far too quickly. And that might be because the quality wasn't there, so the materials are starting to fail, or the architecture wasn't good enough quality, so it's decided the building needs to go, kind of thing. We've all seen that. Other things like functional adaptability, so buildings that are designed from the offset to be used for different functions. We do see now lots of buildings that are repurposed, and sometimes due to the design they can't be, and so unfortunately have to be demolished. So a functional building is a great thing to have that's adaptable. And then lastly, climate change, so resilience to climate change. So if the building is not again, its orientation or other aspects of its design mean that it's going to overheat in the future, and therefore lots of measures have to be put in place, new materials installed or changes to the facades or something because of that. That again is not an inefficient use of materials. So these things are good to consider from the offset. And then looking at the material level for circularity. So if you're looking at trying to reduce carbon from materials, it's really the first thing you do is try to use less material. It's a sort of no-brainer. You don't need to prove it, with analysis to say that if you use less material of some sort of material, you're going to have lower carbon emissions. And so to do this, it's again focusing on what's the functional requirement. And so that could be anything from avoiding massive structures to achieve a cantilever, or big wide spans that perhaps aren't actually needed for the function, but certainly mean you need a lot more material to achieve them. Other things like a poor GIA to net internal area ratio. So if you have lots of an inefficient building, lots of circulation space, large atrium areas or reception areas that aren't actually used for anything, they might look good and impressive, but and there's always a need for that. Like I've said, some buildings last a lot longer because people really like them, so that's fair enough, but these things should be looked at and considered in the round, including with carbon emissions. And then down to even a small scale, like things like partitions, having an extra layer of plasterboard, 2 layers of board on each side, simply to achieve a flush skirting. So is that something that needs to happen? Fair enough if it's a fire acoustic rating, but if it's just for aesthetics, then perhaps not. And that's very similar to the over designing. So can we spend a bit more time designing the on the detail of structural elements or architectural elements, so that we're not using too much material. It takes more time rather than relying perhaps on rules of thumb to sort of fine tune design in that way. And that's maybe a discussion to have about if that's something that can be done on the project. Using modular sizes means that there's less offcuts on site, less site waste. That means less carbon emissions from effectively new materials that will never get used. So that's when planning out buildings, space planning, you know, looking at anything that's modular, trying to stick with that module or use a suitable module. Then you've got the reuse of existing materials on site. So if you can't reuse the structure, then perhaps the existing materials can be stored and then creatively reused on site somehow, instead of being sent off to, you know, to be disposed of or transported a long way to be used somewhere else. And then lastly, you know, if you can't do that, then obviously reusing materials is good anyway. And so if they come from off-site, you know, that's not too bad. Then the next point there is the picking products with lower carbon emissions or lower carbon profiles in the first place. And I have put that second because I think reducing consumption is the harder thing, but the clearer and more effective thing in many cases. And then after that, you should be looking at picking materials with lower carbon emissions. So, you know, exploring alternatives, using LCA, using EPDs to find products alternatives which are going to be beneficial. Then the sort of longer term things like designing for in-use resilience, so materials which are very resilient, perhaps to wear and tear, interior materials, flooring materials, which don't need to be replaced regularly. You know, that have that resilience is going to mean less replacements, less material. But again, you know, you're going to be looking at different types of generic materials in that case, so LCA can really kind of show you overall which one performs best over the whole study period. And then designing for the end of life circular reuse. So this is very long term, but it's the cornerstone of circularity, that you design so that materials can be easily dismantled, removed using mechanical fixings instead of bonding, and so then they will have that second life, that module D that I mentioned, and complete that sort of circular economy circle. This is helped by having standardized, using standard materials, documenting their properties, material passports, for example, and so in the future people can see what material is, what performance it can do, what properties it has. And it doesn't have, say, hazardous ingredients in it, so then it's very clear and there's no mystery around what the products can be used for next time. So just to have a look at the drivers whole life carbon. So I think it's fair to say that with BREEAM, that's been a long-term, you know, area of growth for LCA in the UK. Has been driven by BREEAM. It's originally started off in the Green Guide for Specification, which is an LCA method, but very sort of high-level simplified one. That was there for many years. That gradually started to transition to Building LCA, using Building LCA tools around 2014, and then 2018 update of new construction in the UK was where things really changed. A very significant number of credits are available for doing Building LCA in that scheme. It's difficult to get the higher levels of BREEAM rating without doing that particular part of the scheme. And I think it's it's fair to say that it has paved the way for a lot of the other Building LCA whole life carbon related requirements that you see now, coming out in the last few years. I think it's worth saying with BREEAM though that it can unfortunately become the LCA part, because BREEAM is so vast, it's such a wide range of sustainability topics that it covers. The LCA whole life carbon part can get lost in the middle of all that, and that's a bit of a shame, because what's being required is actually quite a reasonable life cycle assessment methodology, and the results could be very beneficial to the design team. So if it's happening, it'd be good to sort of try and make as much use of it as possible. GLA, I've already mentioned whole life carbon planning requirements, and some of you may know that's been in draft for a couple of years, but it's still been used on many projects despite being a draft. And the final version has come out very recently, and there's quite a few changes in there. It's become more rigorous even than it was before, and it really very much focuses on trying to incentivize reuse. And this is something that needs to be applied to sort of big, large-scale projects in the sort of Greater London area that are called in by GLA. And it's quite interesting because the whole life carbon requirements work in parallel with the circular economy statement and requirements, and they share some of the data. And the circular economy part of it is driving circular thinking, circular principles around reuse and designing for future reuse and many other aspects of circularity. And then the benefits of doing those things will come through on doing the whole life carbon assessment. So the circular economy is the principles, and then whole life carbon LCA is all about the measurement. So just a bit on the sort of background to standards in the UK. So the EN 15978 is the sort of overarching Building LCA standard. It's the one I work on in those committees. It's been around since 2011, believe it or not, and it is being updated now. I think it's due to be released in 2023, and like all standards, it just does take quite a lot of time with representatives from all over Europe working out, how to do this. And since 2011, a lot has changed. There's a lot for it to now cover. It does go into an awful lot of detail, and that's probably why in 2017, RICS released their whole life carbon professional statement, which is very much focused on the UK market. It's intended to be aligned with 15978, which is good because the last thing you want is conflicting or different standards causing confusion. And what it does is it sort of provides default assumptions that you can use in the UK context, particularly at early stages in assessments. You don't always know much about the building, so it's good to have those assumptions. It interprets a lot of the things in the main standard which are a little bit difficult to sort of work out what to do, so it provides a lot of guidance in that respect. And then that means that because projects are being assessed in a more similar UK related way, then you can do comparisons, you can create benchmarks, you can compare your building to those benchmarks and all that kind of thing. And that's why a lot of the industry initiatives out there, GLA, UKGBC, LETI, RBA, are all saying that assessments need to be compliant with this standard, or professional statement, I should say. So net zero carbon for buildings. So there's two sort of elements for net zero carbon in buildings. The first part is net zero carbon construction. So this is for all construction works. It's effectively the embodied part of, as I've described. Then you've got net zero carbon operational, and the two things, they obviously are related. Building performance, they're related things, but for net zero carbon, they're typically done separately. So for the construction works, this is about looking at this upfront scope, A1 to A5, trying to minimise the carbon emissions during the design stage. So this is a bit tricky because the word minimise it's not fully defined what that means generally in net zero carbon initiatives and standards. And so I think generally people look at trying to assess the baseline and then look for options which can produce lower carbon solutions that can be considered by a design team and the client for incorporation. Or it could be that you can demonstrate that your design is favourable compared to an industry benchmark, such as the ones by LETI. LETI have got a kind of rating system now that's a bit like white goods, A++ down to G, I think it is, and they tell you what would be best practice and what would, for now, what's best practice in a few years' time, what's business as usual. So you can kind of get an idea of how well performing the building is there. And then, so you have that design stage activity all about minimizing. That's a very important part of net zero, that you have to be able to really show you've done this sort of minimizing of carbon. Then you have the measuring as built, and it has to be done as built because then it shows the actual carbon emissions for the construction projects. All the designs happened, all the constructions happened, so it's an accurate reflection of carbon emissions at that stage. And then that also tells you the result of that, tells you the residual carbon, how much you need to offset to sort of claim, or that the building is the construction was net zero carbon, and that can all be verified, such as through our sister company here called Natural Carbon Solutions. So that's construction projects, and then you have buildings which are in operation using energy for heating, cooling, power, that sort of thing. And here you also you really need to look at minimizing. That might be through energy efficiency practices, or it might be that a net zero carbon standard or initiative says if the building is under designed, that it has to meet certain energy performance requirements for it, then when it gets assessed year on year in the future, for it to be declared net zero carbon. But that it's all about trying to minimize, and then every single year or a period of time, the carbons, you can just take the measurements from meters, you can work out the carbon emissions annually, and then that can be offset, usually through organizational carbon footprinting and offsetting, and then again that can be verified to sort of show that that's happening, and you can say the building's net zero carbon operational. So just a bit about integrating whole life carbon assessment into the design process. And this is still one of the areas where there is some difficulty, and it's because it really needs to be done early in the process, as early as possible, really. You're looking, it'd be great to look at things actually in feasibility in some ways, but particularly around the sort of concept design stage, where there's some initial ideas about meeting the brief, an initial sort of shape and size, height of a building, an idea of how it's going to be serviced, and then testing out different options, looking for the most sustainable one. And that early stage requirement is recognised in most sort of schemes and initiatives out there. BREEAM, you get the most credits for doing this at stage 2. GLA requires projects to do this kind of activity, whole life carbon and set economy statement at stages. It varies, but stage 1 perhaps, but definitely at stage 2 and stage 3. And trying to sort of show that reduction is an important part of net zero carbon, as I said. But one of the difficulties though is that this is all really happening before planning, and some projects are reluctant to spend time and money on this kind of thing before they've got the reassurance that they're likely to get planning permission. But this is the thing. It's still currently a voluntary approach apart from the GLA. And so really encourage projects to start doing this at this stage, and I'm sure it's going to become a case where more and more local authorities are asking for evidence that this kind of activities happened and emissions have been reduced. You can then you can do a similar process of modelling the current design, looking for options at later design stages, perhaps stage 4, and BREEAM provides some extra credits at stage 4 for this. But it's just something that's good to do on a periodic basis, review the design, look at options, and show that carbon's been minimised, keep good records of how the design's been changed to try and reduce carbon, ready for that net zero carbon claim at the end. And then you have that as built after practical completion, where you're measuring the final carbon emissions. GLA, want that submitted to them. The various ways of achieving net zero carbon need that measurement to do the offsetting and so on, and to demonstrate the claim. And so each of these stages, I mean, like I say, you have that current baseline. This is the classic way it works. Current baseline design designers have, and then that gets assessed by the LCA expert, and then options are developed. And it could be the sustainability consultant is proposing options. Ideally, though, for it to really be a beneficial process, it should be a two-way interactive thing where the design team are talking to the sustainability consultant, looking at where the hotspots are in design, what the main carbon emitting areas, seeing if there's opportunities to make changes. Then that gets measured by the whole life carbon expert, and then you can sort of try and integrate those in that decision in the incorporation stage, showing the client the benefit and the improvement, and then incorporating that, and then you get your next current design ready for the next stage, and you can sort of do it iteratively. So this is my last slide. So just a little bit on roles. So I think with clients, particularly on that need to do things early in the process as possible, this is really about showing leadership, showing the design team that there's that commitment there. They need to act on this, that you're interested in seeing results on reducing whole life carbon. And a good way to do that is through stating your ambitions clearly, setting targets perhaps for design teams to meet. Not all buildings are the same. Lots of sites have quite severe constraints, so I recommend there is some flexibility around that. But it's just a way of sort of, showing this is the target. And if it's not met, then if there's good reasons, then perhaps that's okay. Importantly, the team need to, on the client side, need to have some level of awareness, training, and skills on embodied carbon, so they know what to ask for, they know how to sort of interpret the results, and also making sure that design teams have got the right balance of skills on them as well to achieve what you want to achieve. And then being clear about how carbon mitigation, measurement and communication is going to be achieved on the project. So having a standard way, points in the programme perhaps where the activity is going to take place, being clear about how it's going to be reported, how it's going to be acted upon, roles and responsibilities on the design team would be a great way to achieve that. I mentioned starting early, a few times there, keeping it on the agenda. And also, I think, sometimes it could be that the design team come back and say, look, we can really save a great deal of carbon on here, but it somewhat goes against the original brief, and just having that potential to be flexible around the brief and in response to the findings of the design team for whole life carbon. There's lots of industry initiatives out there, so getting involved with those, particularly on pooling data, being prepared for your buildings assessment to be results to be shared, so that the industry gets really good insight into what good looks like and all that kind of thing. And lastly, there, getting things verified, that raises quality, raises assurance around the results. And then design team and contractors, I've sort of lumped those together because contractors often do have an element of design in them, but it's that kind of constantly looking at the design that's being proposed, that's maybe even on site, and looking for ways to reduce carbon. So here it's around, some clients might not be aware of the requirements, they might not be aware of embodied carbon, so discussing it early, sort of putting it out there and saying, you're interested in this, do you want to do this, right from the beginning, could be very useful. And where a client does have objectives and targets, of course, making sure that's understood by everyone who's working on the project. And it's not something that's just like kicking the can down the road or leaving it until it's possibly too late. So just embracing that and seeing it as a sort of healthy challenge. As with the client side, so ensuring people on the team are appropriately trained and have the skills to do this kind of work and to interpret the results. I mean, it could be that it's not something that needs to be done in-house, but you can appoint a specialist company to do the measurement and to guide in terms of carbon reduction approaches. but it's really good to work with them closely and have that interaction, and rather than seeing it as a source of one step in the design process, get the results, tick the box, but really kind of incorporate it into the design process. Starting early again, I've mentioned that several times, and then just sort of being clear and reporting the emissions at each stage and showing that gradual progress and gradual reduction in carbon emissions to the client, and being able to keep that track record and evidence ready for a future net zero carbon claim. So that's everything from me. So I think we're just over to questions now. I think we're just looking at the list of questions. Bear with us, we're just trying to. Okay, so someone has asked, when's the best time to do embodied carbon assessment? And like I said, it really is important that it's done very early in the project. It's when the big decisions are made. It's to do with the it could be the massing of the building. It's the sort of the key materials like the structure, the substructure, foundations. Ideas around the cladding system, those early ideas around what the building looks like, what kind of shape and size is it, leading up to planning applications, and that's when you want to get this kind of analysis in there in order to really sort of challenge some of those and make interventions where necessary. There are opportunities later on, but in stage 4, but then you're really looking at perhaps different options on materials rather than sort of big picture stuff. I think we've had another one on biogenic carbon. So biogenic carbon is to do with sequestering carbon in sort of timber-based products, and so this is an area of that can get quite complicated. So when a tree's growing, it absorbs carbon from the atmosphere, and then when it's turned into a timber product, that carbon is still locked into the timber, and it will stay there until that timber product is finally disposed of, either incinerated or decomposes in landfill or something like that. And at that point, it effectively releases all the releases greenhouse gases in that process when it oxidizes. So the answer is it's included. It can be included in the assessment. The results can be seen particularly at the sort of A1 to A3 product stage. However, because of that idea around the end of life, meaning that the emissions the carbon that's stored is going to be released, effectively over a whole life, the benefits of biogenic carbon can somewhat be neutralized. So now we're starting to see that different requirements out there saying you should include sequestered carbon, or you shouldn't include, or you should include it at one stage but not another, and it's getting a bit complicated. But effectively, over a whole life, if it's included at the early stages, then it has to be included as a sort of disbenefit at the end, or if it's reported only at the beginning, at the upfront stage, then that's fine, but it needs to be declared whether or not biogenic carbon is included in the results, or it could be reported separately. Okay, so someone's asked why whole life embodied carbon doesn't include B6 and B7. So whole life carbon does include B6 and B7, and that's the whole carbon emissions of the building over its whole life. So whole life carbon is the whole thing. whole life embodied carbon. So the embodied part there, it just means it's embodied carbon over the whole life. So that's to do with materials and products, not energy and water consumption during in use. And the reason that we use the term whole life is to say that it's not just the upfront, it's the upfront plus in-use maintenance and repairs and so on, and the end of life dismantling and disposal. So that's the reason for calling it whole life embodied carbon. And somebody else has asked about balancing transport distance with lower impact materials. For example, if you have a recycled material, but it's going to have to be transported a very long distance compared to a new material locally, which one's better? And it really does depend on the type of material. And the only real way to find out is to use life cycle assessment and do that kind of comparison. If it's a very, very bulky product like a recycled aggregate, very heavy, and it's being driven a very long way, there's a reasonable chance that it'll actually emit more carbon than it would be to use a virgin source that's local to the site. So that life cycle assessment is how you kind of unpick all of that. Another example is if you're using, say, cement replacement like GGBS, which is going to emit less carbon than Portland cement, admittedly, but because of the increasing demand for GGBS, because it's somewhat of an easy switch from one to the other. There are some technical issues around using it, but it's a switch that can be made. It doesn't change sort of the overall design in many ways. But we're hearing now that the sources for GGBS are coming from a very, very long distance from overseas, and so you have to question, what the benefit is, and you have to question sometimes whether the source where it's coming from, what's the consequential effects in that local market. Does it mean they're now using Portland cement instead because the GGBS is being sold at a higher value in somewhere else? So there's lots of these things that can warrant some further exploration. Just been notified that a recording of this session will be available and likely to be during some point next week. Okay, well that's it. Thanks very much, and end the webinar there.